All right, here we go, ladies. Let's take a look at the graphs of other trig functions. Okay. So just as a reminder, last class we looked at sine and cosine. Those are, well, they're sinusoidal functions. They had a sinusoidal axis. They had amplitude. You remember these like A and B. A is the amplitude, B is related to the period. C, we're still not dealing with phase shifts yet. We'll deal with phase shifts next time. And D is the shift either up or down. So we're going to have those same locations. They're going to mean something a little bit different today. Okay, so let's look at the 6 trig functions. So these first two that we talked about last time, sine and cosine, they're very important, right? They're the ones that help us with all kinds of stuff. I mean, we looked at some word problems in our homework last time. So these, notice that they're nice and smooth curves. They just, they go to a 1, up to a 1, down to -1, and so forth. The other 4 that we haven't talked about yet, they look a bit messy, don't they? There's all those pink lines represent vertical asymptotes. And so all the others are just a little bit strange. There aren't any horizontal asymptotes, but there are the vertical ones. And in these pictures, these graphs, they're represented by those pink lines. So let's kind of look at the other 4 and talk about them. Tangent and cotangent over here on the side, they are different than all the others because they have a different period. Their period is either going to be, if you're in radians, it's pi, basically, or if you're in degrees, it's 180 degrees. So those are different for tangent and cotangent. Tangent is even, gosh, he's the strangest one of all, because this is the one that does not transform from the y-axis. So this one does not transform. It's the only one that doesn't transform from the y-axis. All the rest of them do. We don't really have to worry about that yet. We will be worrying about that or dealing with that when we get to phase shifting. But in this case, just know that it's on either side. See how this, that like tan part, that's showing you the parent function. So the parent function, the asymptotes would be at -pi/2 and pi/2. It goes through the origin and it starts down and it ends up. And then it does that over and over and over again. But notice how the parent is situated right in the middle. It's overhangs. It goes into negative, territory. It's like right in the middle. It's the only one that does that. And when we transform it, that makes it more difficult. But just know that its period is pi. Notice that it goes from -pi/2 to pi/2. And that is the total of pi, right? That distance, 1 pi plus 1 pi gives me, 1 pi/2 plus 1 pi/2 gives me 2 pi/2, which is pi. So that's still, period is pi. Cotangent, on the other hand, is a much nicer to deal with because it actually originates at the y-axis. It looks similar to tangent. It's kind of just backwards. Notice how tangent starts down and ends up. Well, cotangent starts up and ends down. That's the parent. And its period, which is pi, is easily seen because it starts at 0 and it goes to pi. It doesn't do the silly going into negative number territory. It just starts at 0 and goes to pi. The parent does. Okay. So now let's look at the other 2, which are quite similar. Those little curves that you see right here, they look like parabolas. They're not parabolas. And we discussed last time about the relationship between the unit circle and these graphs. So if we think about, let's think about cosine, for example. If I start at 0 on the unit circle, my cosine value is 1, right? The cosine value is 1. You can see that 0, the cosine value is 1. When I go over to pi over 2, we know that cosine is 0 there, and we can see that at pi over 2, cosine is 0. And as we continue to rotate around at pi, we know that cosine is a -1, and we can see that at pi, that value is a -1. Continuing on around to 3 pi over 2, we know cosine here is 0. As you can see on the graph, it's 0. And finishing up run rotation at 2 pi, we see that we're back to a value of 1. Now, what's significant about this and what I want to talk about is what happens to secant when cosine is 0. Let's look. So we know that cosine is 0 right here and here, right? It's 0. And so secant is the reciprocal, so we would flip it upside down, right? If we flip 0 upside down, that's bad, right? Because 0 is going to be on the bottom. So notice what happens down here to secant. See at pi over 2, because cosine is 0, secant has an asymptote there. It doesn't exist. That's what causes all of those asymptotes on secant, is when cosine is 0. You see here at 3 pi over 2, cosine is 0. Well, secant is undefined, so it has an asymptote there. And when we graph secant and cosecant, I'm actually going to show you how to graph it using sine and cosine. I think it just makes our lives easier. But that's why those pink lines, which represent asymptotes, are there. It's because that's where its reciprocal function, in this case secant and cosine, that's where cosine is 0. If you look at this pattern, when we look at cosecant, so cosecant is the reciprocal of sine, and notice where sine is 0, cosecant is undefined. There's an asymptote there. That's going to help us when we start graphing secant and cosecant. Okay, I want to pause here for just a moment looking at these are the parent graphs. It's really important we understand the shape of the parent graphs. It helps us tremendously. Are there any questions about the parent graphs that we need to talk about?
So for cosecant, when sine equals 0, cosecant is undefined.
Yeah.
So do we need to memorize like the values on the x-axis, like the -3 pi over 2, -pi over 2?
So those values will come to us from the unit circle. We don't need to worry about that. And as each graph, we would only need that with the parent. The other graphs will be transformed or changed. They may have different periods. So it's not something that we need to have like in our head. It's something that we're going to be able to build as we graph it.
Okay.
We're going to build it from the period. Okay, and there's no, so really the graph shapes that you need to memorize, and I'll just highlight them. You need to memorize cosine's graph shape and sine's graph shape and tangent and cotangent, those shapes. You know, just that in the tangent starts down and goes, ends up, and cotangent starts up and ends down. The secant and cosecant, I have a way around that. You don't have to memorize where those little parabola-looking things are. I will show you how to do that in a much easier way. Okay? And that easier way I'm talking about, I have written out in words over here. This isn't something that I'm going to go through word by word. This is something I have written here so you can refer to it if you've forgotten what I've done, because I'm going to walk through it. I'm going to show you how it works. Okay? All right, so let's go to the next slide. We're going to start out with the most difficult one, tangent. I'm just letting you know so that when you encounter this graph, you're careful. The reason it's the most difficult is because it doesn't transform from the y-axis. That's why it's hard. Okay. So let's go through and identify the parts. So this first number is like amplitude. It isn't really amplitude, excuse me, but it's like amplitude. Our B is 1, so it has the standard period, and we're in radians of pi. This number 3 means up 3. Okay, well, so let's take care of the x coordinates first. We don't have any phase shifts, and its period is normal. So we're going to start at negative pi over 2 and end at pi over 2. That's tangent. So we need, just like on the graphs from last time, you know how we had 5 x values? We're going to have 5. 5 is our standard. We need 5 x values. So I have 2. I'll actually have 3 because 0 is in the middle. So I need to go to the middle of between 0 and pi over 2. That would be pi over 4. And the middle between 0 and negative pi over 2 would be negative pi over 4. And we've taken care of our x coordinates. Okay. Now let's take care of our y coordinates. We want to do the up-down shift first. It's as if we're moving its sinusoidal axis. It doesn't have a sinusoidal axis, so we're basically moving the middle of the graph. And so this says we need to go up 3. So we're going to go 1, 2, 3. So this would be the middle, would be 3. Then my number that is like amplitude, I mean, it's really not amplitude, but it's like it because we need to go up 5. 1, 2, 3, 4, 5. So we're at 8. And then we need to go down 5. 1, 2, 3, 4, 5. So that's at negative 2. So now we have our x and y coordinates set. Questions so far? So on tangent, and actually on cotangent, we start the graph with its asymptote, and we end the graph with its asymptote. That's one cycle. I would start in the very middle. Its middle point normally is at the origin, but we have shifted up 3, so it's right here. That's its middle. Let's think about, we can look at the other graph, but I want to think about the unit circle. So we know tangent is sine over cosine. So tangent is sine over cosine. So here at 0, it's 0. At here, at pi over 4, does anyone remember what tangent is at pi over 4? It's 1, because it's root 2 over 2 over root 2 over 2, which is 1. So here at pi over 4, it would normally be at 1, but we have shifted it, right? It's up here. And at negative pi over 2, it would normally be where? If we were down here at negative pi over 2, negative pi over 4, what do we remember what that y value is for tangent? It's negative 1. It's negative 1, right? Because tangent, sine over cosine, sine is negative down there, cosine is positive. So here, I'm going to be down here at the low part, so down here. I guess I'm just going to move that negative pi over 4.
How do you know, like, where to graph it? Like, are you adding the original value to, like, the amplitude or the up 3? Like, how are you?
Right. So I would take the original value. If we were doing transformation by points, then I would take the 1 and I would multiply it by 5, and then I would add 3 to get the 8.
Okay.
Or I would take the -1 and I would multiply it by 5 and then add to 3 to get the -2 if we were, you know, transforming points.
Okay.
Here, we're simply recognizing the shape. We know that it starts down and ends up, and that the middle is going to reside where this is, the up, down. If we went up or down, that's where the middle is going to be. And the top and bottom points are going to be affected by this number that we look at like amplitude. And that is our tangent graph. How are we doing? Okay, let's look at our cotangent graph. So this number is like amplitude. Okay, this number affects the period, so the period equals, and it's cotangent, so and we're using degrees, the period equals 180 degrees over 18, or the period is going to be 10 degrees. And this number is down 5.
Why did you do it over 18?
Because that's B. That's this. Remember our little formula, which is period equals, you know, the normal period, 180 over B. That's our formula for muscle. So that's a little formula you just need to have in your head. For tangent and cotangent, period equals pi over B. For all others, period equals 2 pi over B in radians. Of course, we could convert to degrees if we wanted to. Okay, so let's start graphing it. Let's start with the x's. We don't have any phase shifts. We're not going left and right, so we're going to start at 0 degrees, and we're going to go all the way to 10 degrees. This is cotangent, so it's much nicer than tangent. We start at the y-axis, very nice. So then I would half that. Half of 10 is 5. And then I would half again. Half of 5 is 2.5. 5 plus 2.5 is 7.5. And now I have my x coordinates set. Y coordinates, I'm going to start with the up-down shift. This is down 5. So I'm going to go down 5. So this is -5. That's the middle. And then I'm going to use the number that's like amplitude. I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is that? 4. And down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is what? 5, what is that? -14? Okay. All right, so we start and end on tangent and cotangent. We begin and end with the asymptotes. So let's draw those in. I'm going to place the middle first. The middle point should be in the middle where the up-down shift took us. This was a down 5 shift, so that's the middle. Now I just have to decide or remember if this is tangent or cotangent. Okay, if it was tangent, I would start down and end up, but it's cotangent, so I start up and end down. And the point is going to be at the x values that we found and the y values that we found. We're not looking at any other points besides those specific points. And so we draw it. Okay, that's terrible. And there's our graph. All right, questions about cotangent? Okay. So now let's move to secant and cosecant. And what I'm going to show you, I think, is the easiest way to graph them. This is how I'm going to teach you, I think, the very easiest way. And that is to remember that secant is the same as 1 over cosine. We need to remember secant is the same as 1 over cosine. Okay, and we'll get to that in just a moment. So this is like amplitude. This is, let's see, so the period equals, and we're in degrees, so 360 degrees over 5, and we divide that out, we get 72 degrees, and this number means up 6. Okay, so we're going to start at 0, and we're going to go to our full period, which is 72 degrees. And to get the other numbers, we're going to half and half again. So half of 72 is 36. Half of 36 is 18. And so 36 and 18 is 54. And those are our x values. Okay. Now let's use our up down to get our center set. This wants us to go up 6. So 1, 2, 3, 4, 5, 6. I'm going to actually draw a sinusoidal axis here, just like with sine and cosine. I'm going to go up 3, so this was 6. I'm going to go up 3 to 9 and down 3 to 3. Okay. Now, the way, I think the easiest way to graph secant is to graph a shadow cosine. This is like a little dotted line guy. Now the thing that we need to, there's a little bit of a trick here because that's negative. It's negative. So let's think about our shapes for cosine. Let's think about our shapes. Cosine. So cosine starts at its maximum and then it goes down and back up to its maximum. This is its minimum. That's what a regular cosine looks like. So what do you think is going to happen to a negative cosine? Where is it going to start? What's going to happen to it? Ideas? It's going to flip upside down. Okay, it's going to flip upside down. It's going to start at its minimum and then go up to its maximum and then back down. It's going to look like an upside down U. So since this is a negative 3, we're going to draw the, I just call it a shadow cosine, starting low, starting at its low at 3. And then we go to the middles, and then we go to the max, and then we go back down to the middles, and then we go to the low, and then I just do a dotted line here. Now some of my students before really get upset about the dotted lines and they want to erase them after we're done. And if you want to do that, go for it. Just erase them. I just leave them there. They're not hurting anything. They're not really part of the graph, but they're not hurting anything. Now let's think up there, where was it that our if we turned it upside down, so let's just remind ourselves. Remember when cosine was 0, that caused secant to be undefined, right? When we flip 0 upside down, we're undefined. So we're not actually at 0, we're at 6 because we shifted up 6. So everywhere we cross the sinusoidal axis, there needs to be an asymptote. So I don't even have to memorize where their asymptotes are. I just draw it off of the shadow cosine. And whenever I see like this right here, this maximum point, that means that there's going to be a little parabola looking thing coming up off of it. The little parabola looking things never point to the middles. They always point out. So there's another little half of a parabola looking thing here and half here. Now I'm going to remind you that this graph would continue, right? It would continue. So if the little half ones really bother you, you could do a whole one. You don't have to do a half one. And this likewise on the other side. It's just that you would be doing more than one cycle is all. But you can do that if you want. If you don't really like the little half ones, you can take it, the other way and finish it. Or you can just leave it as half ones. I usually leave it at half ones. I'm okay with that. Okay, I am okay with that. Are y'all okay with that? Okay, so that's how you would do it. All right, let's take a look at number 4. Does anyone need number 3? Are we okay? Good to move? Okay. All right, let's do this one. Okay, here we're in radians. So this number is like amplitude. Okay, this affects the period. We're in radians, so the period is going to equal 2 pi over 8, which reduces to pi over 4. And this number means down 3. Those numbers tell us what to do. They're our guideposts. They tell us exactly what to do. Okay, so we're going to do the period first. We're going to do our x's first. We're going to start at 0 radians, and we're going to go all the way out to pi over 4 radians. That's one full period for this one. Now we're going to half and half again. So half of pi over 4 is pi over 8. Half of pi over 8 is pi over 4. And so let's see, I have, half of pi over 8 is pi over 16. So I have 1 pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16 is pi over 4. Okay, I like the whole counting thing. It helps me. Okay, so there's our x coordinates. Now let's move our center. We're not at the x-axis. We're shifted down 3. So 1, 2, 3. So we're right here. I go ahead and draw the sinusoidal axis because why not? Now let's use our amplitude. It's like amplitude. It's not really amplitude. So we go up 7. 1, 2, 3, 4, 5, 6, 7. So that's at 4. That's at -3. And down 7. 1, 2, 3, 4, 5, 6, 7. So that's like -10. Okay. Now this is cosecant. Let's remind ourselves of the shape that's reciprocal. So we know cosecant, and we'll write this out. Cosecant is the same as 1, or is the reciprocal of 1 over sine. Those are the same. They're equivalent. So the parent of sine looks like this. All right, that's what it looks like. So that's what we're going to do. We're going to start in the middle. We're going to go up to the highest part, down to the middle, then down to the lowest part, and then to the middle again. So there's our shadow. So everywhere the shadow touches the sinusoidal axis is where there's an asymptote. So we have one here, we have one here, and we have one here. Okay, can you see where the little parabola guys are going to go? The parabola looking guys? I don't want to hurt their feelings, they're not really a parabola. I know. You see how this one is going to go up? Because it just sits on top of that little mountain. Think of it as a mountain or whatever. It goes up. So what is this one over here at 3/16 going to do? It's going to go down. Because they always go away from the middle. They never go towards the middle. They're always away from the middle. If you're ever confused. Always away from the middle. And that's our graph. Okay, yes ma'am.
On the test, would you be able to like draw this?